Hello, in this video we're going to work through number 7 on worksheet 4. Now this was a problem from your problem set, just different numbers here, and there's an easy way to do this with some graphing and some arguments about slope, but there's also a little bit of a longer, more algebraic way. So what we see here is that M, P, and N are the midpoints of this triangle. So what I can do is since we're talking about midpoints, what I'm going to do is I'm going to use the midpoint formula, which is x1 plus x2 over 2, y1 plus y2, 2 over 2. And a nice thing to remember here is the fact that these are broken up into the x part and the y part. So the way I'm going to actually approach this problem is I'm going to deal with all the x values, and then I'm going to deal with the y values. So let's take a, b, and c and give them variables so we know what we're talking about. So a is going to be xa, ya. B is going to be represented by xb, yb. And c is going to be represented by xc, yc. Okay, so now if we start with m, we know that m is the midpoint of a and b. So that means that xa plus xb over 2 is equal to, and is 1. And we can then rearrange that to get xa plus xb is equal to 2. So now, if we take a look at p, we see that p is the midpoint between a and c. So therefore, if we have xa plus xc over 2 is equal to, and then we want the x point for c, which is 2, 2, and then we can rearrange this to xa plus xc is equal to 4. Now if we take n, which has an x value of 3, so in n we see is between b and c, we know that xb plus xc over 2 is equal to 3, and therefore we get xb plus xc is equal to 6. Okay, so now that I have this really becomes a little bit more complicated problem in terms of just having a systems of equations. So if I name these equations 1, 2, and 3, I can rearrange them and start doing some substitution in order to remove all the unknowns but 1. So what I'm going to do here is I'm going to start with equation 1, and I'm going to rearrange equation 1 to say xb is equal to 2 minus xa. And let's call that equation 4. And then what I can do is sub equation 4 into equation 3. So now that means that, I'm sorry, I did this backwards. So we want xa is in equation 3, so xa is equal to xb. There we go. So just so you see what I did there, I've rearranged to get xa, because in equation 2, we're going to into equation 2, pardon me there. So what I've done is rearranged for xa, so I could substitute xa into equation 2. So therefore, let's just come up here. So we're going to get 2 minus xb, 2 minus xb plus xc is equal to 4. So notice what we've done is we've substituted this value here to there. So therefore, we can say that xc is equal to 4 minus 2 plus xb. So therefore xc is 2 plus xb. So we'll call this equation 5. And let's actually come right up here. And then I can sub 5 into equation 3. So therefore, we have xc is equal to 2 plus xb. So therefore, we can say this is equation 3 here, xb plus 2 plus xb is equal to 6. So 2xb is equal to 6 minus 2. So 2xb is equal to 4, and xb is equal to 2. So therefore, if xb is equal to 2, and we know that if we go back and follow through here, we know xa is equal to 2 minus xb, we can say xa is equal to 0, and let's go back up here. If we know xb is 2, we know xc is equal to 2 plus xb. We see that, therefore, xc is 2 plus 2, which is equal to 4. So now we have, and let's just take a different color here, and we see that we have xb, we have xc, we have xa. So what this simply is a system of equations with three unknowns and 3 equations. Pretty mechanical. So now that we've dealt with the x's, we can do the exact same thing for the y's. So let's do it in a different color now. So if we take a look, we see that. Okay, so now let's work through this. My phone might ring in a second. It seems to be ringing tonight. So now let's do the same thing but deal with the y values. So what I'm going to do is I'm just going to come down here a little bit. And what I'm going to do is I'm going to write, just to remind myself, that m is going to be 1, 3. So I'm just writing these points. So m is 1, 3, n is 3, 4, and p is 2, 0. Okay, so now that we have these points here, what I'm going to do is I'm going to set up my equations. So therefore, ya plus yb over 2. So we're going to add the 2 y components and take a look. Let's look again. A and b, the midpoint is m, is going to equal 1. So therefore, we get this equation. Ya plus yb is equal to, actually, I think I've made a mistake here. Let's scroll back up. Oh, m is 3. So let's come back down here. So that shouldn't be 1, that should be 3. Is 6. So then we're going to get yb plus, actually, let's stick with the same pattern I did with my x's. So we have xa, xb over 2, and then we have xa plus xc. So we're going to do ya plus yc over 2 is equal to, and let's look, a and c, so the midpoint is p, is equal to 0, so we get ya plus yc equals 0. Ooh, and this looks really great, because look at this. Let's just do this right now. Ya is equal to negative yc. That's pretty great. Okay. So, okay, and then we get xb and xb, so we're going to have yb plus yc over 2. And again, I notice I always go back to my diagram and take a look. B and C, and the midpoint is n. So we take a look and we see n is 4, so that's equal to 4. So therefore, we can get yb plus yc is equal to 8. So let's call this equation 1, let's call this equation 2, and let's call this equation 3. And remember, the wonderful thing here, this is 0, so we're going to sub, if we know, let's see, ya is equal to yc, so actually it doesn't help us immediately here, so because we can't, this is yb and this one has ya and yb, so it doesn't help us wonderfully. So let's do this. Let's just go through the same process. So we're going to say ya is equal to 6 minus yb, and just so you know, I'm not copying this off of some solution somewhere. I'm doing this as I go, and I think it's really important that I do that so people see the thinking that I put into these as I work through. So let's call this equation 4. So therefore, if we call this equation 4, we know that we can sub 4 into 2. So therefore we get 6 minus yb equal to minus yc. So therefore, a little rearrangement here, and let's say 6 plus yc is equal to yb, and let's call this equation 5, and let's sub 5 into 3. Let's come down a little bit more. So we get 6 plus yc plus yc is equal to 8. So 2yc is equal to 2, and therefore yc is equal to 1. Perfect. So, therefore, if yc is equal to 1, and we know that ya is equal to minus yc, ya is equal to minus 1. And if ya is equal to minus 1, and we know ya is equal to 6 minus yb, we know negative 1 is equal to 6 minus yb. So a little substitution. And again, there's lots of ways you can do this. Yb is equal to 7. So let's get our change of color here, and let's just, there's yb, y's a, and there's yc. So therefore, a is 0, comma, let's see, ya is minus 1, b is 2, comma, 7, and c is 4, comma, 1. And if we take a look at these, based on the sketch, they seem to make sense. So that's how we do this problem. It's really just a system of equations, and we have to set up our system by first finding the midpoint formula. We're using the midpoint formula. And one of the key things here is that the midpoint formula is nice because it sets up the x and y's in separate kind of compartments. We deal with the x's, work it out, and deal with the y's. So I'm going to make another video in a second, and that second video is going to show a graphical depiction of this, and we're going to show a really quick way to do this problem. I hope this video helped.